stream. Just announcing this on Twitter and then we'll get started. This will be a relatively low talking, kind of chill format. Let me know if the fan noise is too much. I've been trying to keep this room pretty quiet, but unfortunately some of the electronics equipment here, like the power supply and the O-scope, is actually pretty loud. If I'm actually trying to communicate, I'll probably actually be next to the mic, but like I said, not much talking. Got such a lovely view of Tuco here. Such a relaxing cat, right? some concern over the color of my cat. I assure you he's still brown. I think he just looks really bright in that image because there's a lot of light where he's sitting. It's actually really bright in here. Mostly because I needed a lot of light to make the green screen work and to actually get good pictures of the stuff on the desk without it just being washed out with green. I was going to actually try to monitor the audio here, but my headphones have kind of self-destructed. A little better. I really should get some headphones that have a better connector on them. Testing. It's a little bit too much. That might be a better microphone to use while I'm at this side of the desk. So happy Friday, everyone. I was going to see if I could demonstrate this thing booting and getting into the BIOS. I did do that off camera just before the stream. It'd be nice to actually get that on recording though. So we were looking at this screen. I unmounted this. Totally unmounted this from the enclosure, and it turned out to be a surprisingly beefy little chungus here. I ended up having to put these standoffs on it just to give it a okay way to sit on the table. It's got this fairly heavy frame and then a bunch of oddly shaped circuit boards on the backside, so really nothing to sit on that's actually not fragile. We could move it and look at the backside at some point, but it's not that interesting. It's like a backlight inverter and an LVDS receiver. Yeah, and some like transient suppressors that are used for the touchscreen, but not the actual touchscreen electronics. Oh yeah, the Heiko board holders are nice. I was just thinking earlier it would be cool if I had more than one of those, but they are really expensive, which is why I only have one. Like, it's great for small boards, but I don't have enough of them to make it useful for boards as big as these. Alright, so we've got the LCD assembly, got the motherboard. So there's a couple of these unpopulated connectors because I haven't plugged in all of the peripherals. This one normally goes to a parallel and serial port. The parallel port is for the like vote receipt printer kind of thing. The serial port goes to an external audio module that I don't have. And then this port over here on the right side, this one goes to the smart card assembly, which is in the other half of the case, and I didn't bother removing it because I don't think we need it yet, but it's pretty simple. It's a little circuit board that has what appears to just be some like power supply and transient suppression stuff, and then the actual mechanical smart card slot. It's got a little solenoid for the eject mechanism, so it's got a power transistor to control that. Oh, that's BIOS. Cool, we got lucky. Let's get a better view. Oh, already turned off. So that's the problem. I mean, one of the problems. Yeah, so it could be a variety of things, but I think there's some kind of watchdog timer going on. Now that we have easy access to the board, I kind of want to do just another pass on looking at power supply voltages just to make sure there aren't any obvious problems there. And we can get most of those off of the PC104 connector, maybe probe the capacitors next to the system on chip and the video chip. But I think the next step I'm headed for is to connect the logic analyzer to the PC104 bus and then get some traces from that with pulse view. I just need some kind of reliable test. Like part of what's frustrating about intermittent problems like this is I want like one reliable thing I can do repeatedly to get information. And this seems to behave a little differently every time it boots, so there's definitely something I'm not seeing that would be useful to see. It would actually be useful to get some debug signals from the power management chip. This guy right here. Yeah, so that's a kind of single chip multi-output DC to DC converter, you know, kind of power sequencer, power management chip designed for laptops. The Max 78, Max 782. Yeah, Max 782. It'd be cool if there was some kind of existing debug header we could tap signals like that off of. I'd noticed that there's a second fuse on this board. So, yeah, that's the primary fuse. This cable is where power comes in from what's normally the battery charging board. I have that board over here just kind of getting fake battery power off of a bench supply. That is the fuse that the main power input comes in through. But yeah, I also noticed there's a secondary fuse over here. Based on the location, I'm assuming that might be related to the power supply for the printer. This connector goes to the printer's power input via a little kind of expansion port board. This computer needs more RAM to be a good PDF viewer. Just let that swap for a while. This part right here is kind of a fun blast from the past. This is back when laptops were expected to provide programming voltages for the memory in their memory card slots under certain conditions. So like this VPP is a switchable programming voltage that can be 5 volts or 12 volts or high impedance for PCMCIA cards. It's kind of funny. And because this board has 2 of these PC card slots, I don't know whether those cards actually need a programming voltage, but it's possible they're actually using that feature. That would be kind of funny. Oh, soft start. One weird piece of behavior I did notice is, and this was something I only noticed after getting the circuit board out on the bench here. There was too much going on with the enclosure for me to see this before, but it looked like the power LED was kind of fading on rather than turning on sharply. And that could be a problem, but it also could be an actual soft start circuit. And it seems like this power controller does have soft start capabilities. Yeah. That connector for the printer power might actually be a convenient O-scope ground. Oops. Right. One thing I noticed working on this earlier, I was just like snooping around with the thermal camera, and the speaker coil was surprisingly warm with the thermal camera. So like I don't think there's any like AC filter or DC blocking for the PC speaker. I think it's basically just like driving the speaker with 5 volts most of the time, and then beeping occasionally. And yeah, one side of the speaker coil is actually just connected directly to the 5-volt rail, and I guess the other side they're pulling it down through probably one of those hex inverter chips or something. Like the electronic design for this board is just kind of weird. I already mentioned there's just a huge number of level shifters on this board from all the mixed 3.3 and 5-volt logic. So this should be the system 3.3 volt rail, fairly close to the system on chip. Okay, well that... It's actually booting up now. When it boots this far, I think it tends to not actually shut down by itself. I've been avoiding killing the power while it's booting in case it's maybe like writing to the file system then. But like at this point, I don't think there's a way to get it to shut down other than actually pressing the reset button or killing the power. Yeah, this was also harder to hear with it in the case, but you can hear a click when the power is applied or removed from the PC speaker. So we'd probably see the coil heating up that little plastic cone. Okay. Let's see if we notice anything weird with a couple of power cycles on a longer time scale here. That looked like a beautiful little ramp up. I don't see anything weird about the 3v3. We could look for something high frequency, but... If this is like an electronic problem, like with a hardware component, I don't know if it would be power, but there's so many little interface chips that, maybe there's just like a logic chip that has a stuck transistor, a stuck output somewhere, and that's causing the boot up process to be unreliable. Okay, that was actually it powering itself off. So it's sleeping now. I could wake it up again by toggling the power switch off and then back on. There was a step in there. I didn't totally catch what it did, but that looked like it might have been some kind of multi-stage thing or like a soft start. Okay, I'm power cycling it with the switch in the on position. Only 300 milliamps. That was something in my setup here creaking. Okay, and that looked like a pretty orderly shut off. Let's just power cycle it again. LCD backlight came on this time. I mentioned before, but that seems to be a little non-deterministic. I mean the backlight of the LCD that's off screen, not the big one that we're looking at. But there's a little text LCD here, which is currently blank, but on. Another power cycle. This looks pretty normal, assuming nothing weird happens. I'm just gonna switch to 5 volts next. I do want to know if there's a watchdog timer, and if so, where it's implemented. It might just be part of the system on chip, so it might be worth skimming through the documentation for that again. Okay. Let's grab 5 volts. I don't know, but I'm going to guess maybe this capacitor next to the Super I/O chip has 5 volts on it. Let's find out. That's interesting. I wonder if the 12 volts is low because the input is simulating a somewhat discharged 12 volt battery at the moment. That's interesting, but I don't really want to go there yet, so I'm going to try this other capacitor. That is tracking the input voltage as I change that. That might just be part of the battery measurement circuit. Okay. There's another big... Oh, you can kind of actually almost see that. Yeah, that's next to the graphics chip. I think they're running the graphics chip on 3.3 volts. It's actually designed to run on either, but I assume they would want to run it on 3.3 volts because I think all of their LCD stuff is running at 3.3 volts also. Just use the no. It's okay, we can connect the ground through a giant inductor. That camera that's on Tuco is actually the same one that would usually give us that infamous servo AF, but I finally put a new version of Magic Lantern on it and got the clean HDMI working. Just power cycling it a couple times and looking at the 5-volt rail. So far, this is all extremely normal. I'm going to look at the PC104 bus next. My main goal here is to actually hook that up to the logic analyzer so we can watch the post codes go by on the bus. But I do actually want to look at it on the scope first just to see if there are analog problems before we, bury our head in the digital sand. Okay, so that was 5. I don't even know if we have a -5 on this system. Does not look like it. think we'd have minus 12 either. No. We should have plus 12. Maybe not on the PC104 connector, though. Let me double check I'm in the right spot. Yeah, I'm guessing they just didn't hook that up. Anyway, let's get IOW next. That actually should be very interesting. And okay, it's off. Oh, it's fully booting right now. Why am I not seeing any IOW? This might just be way too fast, or double check my connection. Oh, I think my probe was actually hitting the plastic right next to the pin instead of the pin. This is much better. This is bus activity. Huh. That was pretty weird. The noise is not usually that drawn out. Now I'm wondering if somehow I caused that by adding a little bit of capacitance to the bus. I doubt it, because this is a very slow bus and a very fast oscope probe. But I am also just kind of wondering if maybe there's a general like oscillator problem on this system. So maybe we could poke around there too. Weird noise. Okay. Is the bus still talking? That's IOW, I think. Yeah, I think it's just like in a halt loop at this error dialog. So I'm gonna hit reset. And it's in sleep mode now. So maybe I'll just power cycle it. And now it's doing the thing where it draws 300 milliamps and gets stuck. I think if we look closer at it in this state, though, like because I did the same experiment a couple days ago, we will actually see a few bus writes before it seems to get stuck. I'm going to change the scope settings. Yeah. So now I think this might repeat if I hit reset. Yes. So if I keep resetting it while it's in whatever this state is, this is something that's happening in the BIOS, and it won't actually, like if I soft reset it back into the BIOS post, it won't power off the machine immediately. It keeps the power actually on. So this seems like good activity to try to capture on the logic analyzer. Okay, now it's actually off. Well, while we're in the analog domain here, I want to find some clock sources and see if they're okay before we dive too deep into the bus. I don't know if they're actually going to have the clock exposed on the PC104 connector, but that's totally the first place to look. I think we want bus clock. Okay. Bus clock. Nothing. It could be useful to actually trigger on that IO right, just to have something else known on the scope. But I think, I don't know. I wouldn't be surprised if they didn't want to send the clock signal to the card. Now I'm wondering if that PC speaker is connected to the Super I/O chip or to the system on chip. I'm just going to start sticking the oscope probe into oscillators. This is 24 megahertz for the Super I/O chip. Okay. Yeah, so I think the Super I/O and the graphics chip have their own oscillators, like entire oscillators, not just crystals even. These are like 4-pin oscillators. And then the system on chip I think runs off of a 32 kilohertz watch crystal and then uses a PLL to generate everything else internally. Okay, that is the 14 megahertz. 14.31818. So sure, that's for the video chip. Ah, big old Chungus wave. Yeah, that's the watch crystal. And this is not even going to be an accurate way to measure it, probably, because the scope is going to load down the circuit. I really want to find something that's amplified and derived from this. Anyway, no obvious clock problems. We could just grab a data pin from the bus, so something that would be correlated with the processor frequency, but, you know, measuring it wouldn't affect the frequency. Let's just grab the least significant bit on pin 9 on row A. Oh, you know what else? This is probably only going to have the bus activity that needs to go to 5-volt devices. I don't know. Oh, there we go. Yeah, that's at least the bus activity that's related to the stuff that we were seeing earlier. So I think a lot of this stuff is BIOS debug activity and or the BIOS talking to other peripherals that end up kind of leaking out to the same bus. Display. I'm forgetting where the persistence menu is in the scope. Okay. Yeah, this is just going to be kind of a mess from all the different drivers on the bus taking control over this. I'm going to go back to I/O right. I could actually clip this on. Okay, this is a bit more stable. There isn't like wild frequency variation in the length of the pulses, but definitely a little bit of shift about when things happen. Anyway, I was just alarmed by what sounded like a error beep at a frequency I hadn't heard before. Seems like an interesting clue. I don't know if that's a clue to hold on to for later or something to deal with now. I also don't actually know how the touchscreen controller, speaking of things that are failing in the boot process, like how that's actually connected. There are a number of sensible options. It could be GPIOs, or it could be the actual PS2 port. It could be, some other bus mapped device. It could be a serial port, I'm guessing that for software compatibility, they probably would have wanted it to look like a PS2 device, but it's, who knows? Cat hairs all over this. All right. I think we're going into Logic Analyzer. So I'm going to start with just the data pins, so SD0 through SD7, and then I only have 16 bits to deal with, so I can't get even all of the control signals and, you know, a bunch of the address bus, so I have to be really picky about what I'm actually picking up. Since I'm mostly just trying to debug postcodes in the BIOS, I really want to be able to find I/O writes that happen on port hex 80. So if I can get I/O write and then just a bunch of address bits that will help me disambiguate between port 80 writes and everything else, that would be great. So probably like a lot of the I/O writes happen within the first 256 addresses, so like I'm thinking maybe just ignore the upper bits and focus on that lower byte of the address, and then within that lower byte I can't even get that entire thing because I need at least one control pin. So maybe I'll try to get, like, you know, bits 1 through 7 or something of the address bus. If I were wiring an FPGA up to this, it would be really tempting to just like bodge wire the whole thing onto the input side of these level shifters so that I get 3.3 volt. But luckily this logic analyzer can handle 5 volts. It's already full of level shifters. This whole thing is just made of level shifters. Normally these headers are not populated, but we populated them on the last stream. And so I already have actually some interesting binaries from this. The application lives on this card, which is a standard compact flash card. Pretty trivial to read. It's just like a DOS file system with files on it. Most of the application is in just a big flat binary file that's you know, got all their libraries and everything pre-linked into it, so pretty easy to analyze. I also got a BIOS image off of this thing, and that was an interesting little detour that I think we got on stream back in 2018. But the way, if from rereading my notes, because I don't remember doing any of this, but I took notes on it, and I think what I was doing then is I patched the application by modifying the flash card, and during the application startup, put in my own assembly code, and then used that code to set up memory mapping. So I had to like program the memory mapping registers on the system on chip to get access to all the ROMs, and then I could walk through all the ROM, reading it out, and my output device, like there's a bunch that I could have used, but I already had a logic analyzer attached to the compact flash port / hard disk port, which is right over here. The compact flash slot and this hard disk connector are both actually attached to the same hard disk controller. So I was using that as a debug output, and so I could just like blast that out to the hard disk port as a way of saving a copy of the BIOS. So we've got a BIOS dump, and that might be super interesting to match up with what we're seeing on this logic analyzer in a minute. Alright, so we have 7 address pins here, 2 grounds, 8 data pins, and the I/O write control signal. And that's all connected to this Salia Logic 16, which is plugged into a Raspberry Pi over here, which we'll be running Pulse View on over Remote X. Oh, I don't have a good keyboarding situation over on this side of the desk. All right. Okay, I think this is going to work. I might just have to time this so that we actually get the data in the buffer. And hopefully the Raspberry Pi doesn't run out of memory. Oops. Gotta remind myself how these are even numbered. Yeah, that should be the right pulse. Having second thoughts about running this over Remote X on the Raspberry Pi. I feel like I'm probably going to just end up wanting to write a Python script to deal with this particular situation, but I'm giving the GUI tool a try because it's usually the easiest thing if it actually works. But like last time when I was doing debugging with this out the hard disk port, I think I had some scripts written for that. I think I actually wrote my own pulse view decoder actually, so I probably still was using the GUI tool, just automating it a bit. Maybe I should just change the display resolution on this. I wonder if Pulse View respects DPI scaling. It's just really little on my screen. Oh, dear God. Gosh. I would like to be able to collapse the ones that I'm not using anymore. Did I disable the channel entirely? Yeah, I might need a different setup for this. This like Remote X thing is not, like I did try this before streaming, but it is not quite as tolerable as I was expecting it to be. It's not gonna move this up. Okay. Sure. Such a good cat. Maybe I can just do this on the command line. Hmm. Like a cat. SIGROC not finding the firmware files, maybe? Maybe that's not a problem, actually. It looks like it fails before it sends the firmware, and then it sends the firmware and the device is fine. So maybe that's... maybe I can ignore that. hoping SIGROC had a nicer way of dealing with parallel buses, but I think I just have to wire these all up separately. Where'd you go? Tuco. Tuco. I don't see a way to name the different protocol decoder stacks on the command line. Oh, Tuco wants me to open the door, but it's kind of cold outside. That's gotta be the defaults, right? Okay, Tuke. Oh. Talkie. Yeah, I think I can see why I was writing a custom decoder for this last time instead of using pulse view. So it's partly because I don't have a great way of running pulse view on a machine that actually has enough RAM to just collect huge traces. But it's actually super nice just to write a decoder that gives you like text output for this stuff, and then you can just run it continuously on the command line. So might do that. Hey Tuco, Tuco wants attention right now. Tuco. Such a cat. Alright, so that's cool. I kind of do actually want like ASCII output. I mean, I feel like some of this is going to be simple enough that we can just look at what's going on in the command line without having, you know, like in the terminal window without having a whole bunch of decoding. Is that just what we get by default? Hey, Tuco. Hey. Tuco. Hey. Hmm. Hey, Tuco. Tuco. Chico, what are you into right now? You want to chew on stuff? Gosh. Oh. Hey. Honey. Now he's just licking everything. Now he's biting the microphone cable. Tuco. Dude. He is up to no good right now. Hey. Honey. Honey. Zuko's gonna sit on my keyboard. I'm gonna play with his ears. He's still sitting directly on top of the keyboard. Ah. Got a big old soft floppy head. Did Tuco open a software update dialog box somehow? I think he managed to close it at least. And now it's back. Yeah, I think... Oh gosh. Don't step over there. Okay. Just put a giant smudge right on my glasses. Press any key to stop acquisition. Actually, none of the keys stop acquisition. Too good. You went out. I think he just wants attention. He's pacing around. Okay, I was expecting this to write output to standard out. Wow. Hey. Sweet tiger. Hey. What are you doing back there? Do you want out? Out there too. Yeah. Okay. Have a little bit of cat-free time here. Okay, that gives me standard out. I mean, in any case, I'm probably going to have to write a decoder to get the behavior I actually want here. Because this is, like, this parallel decoder is either going to give me, like, one record for every clock cycle, or maybe it's just going to give me one record for none of the clock cycles, which seems to be what I'm getting now. Gotta remind myself how to actually install and write these decoders. The other option is I could go read a bunch of SIGROC documentation off stream and then come back at this fresh tomorrow, but I'm trying to get into an actually regular streaming schedule, and I don't know if I can handle starting at a regular time of day, but I want to at least see if I can stream like every day. Like, it feels like that was one of the things I really wanted to get this studio set up to be able to do more readily. And here we are. And I kind of like this format where I'm explaining fewer things. now Tuco wants that door open again. Oh, from chat, Tuco is indeed polydactyl. It's cold. Hey, Tuco. I love Tuco, but it's very difficult for me to concentrate when he wants attention. Hey, boy. And like sometimes he is okay with just being held and like letting me call the shots, but it's like sometimes he really wants to be the boss. He wants me to stand where he wants me to stand. And when he's in one of those moods, it's hard to actually concentrate on stuff unless I'm like very actively ignoring him. Like big headphones with white noise, kind of actively ignoring him. Yeah, I think this is where to actually go, but I'm wondering if we can get some just really quick and dirty data by just using the hex output. Because I do want to just even get some confirmation that the postcodes we're looking for are here, and to just get a rough idea of how much else we're going to get in addition to the postcodes. Here you go. Oh, this is hex states, not one hex per. Yeah, that's not really useful either. This is like one line per bit. It's like I need to rotate the matrix. Control C is just in general not working when this thing is waiting on USB I/O. Tuco, are you going to destroy my already broken chair? Climbing the walls over here. That's handy. just wanted to paste. I didn't want mouse support in Vim. This might need some updating for current versions of SIGROC. I'm sure I wrote this in 2018, so it's at least 3 years old, SIGROC. Oh, this is so small. Maybe I just need to copy that into this decoders directory. Or, I mean, either that or they're importing common differently now. This looks similar so far. Alright, maybe that's it then. Okay. I think now the problem is that the library I downloaded from Git is much newer than whatever SIGROC is included in Raspbian. If I'm going to be hacking around on SIGROC stuff, it would actually be nice to be using top of tree. maybe this would be an okay time to wrap up tonight's little stream, and I'll do a little bit of yak shaving off camera to get this all built and set up in a way that we can actually hack around on protocol decoders. And that, I think, is going to be the next step to actually see what's going on. Like, we could just look at this stuff in pulse view, but I feel like just looking at a bunch of squiggles at the moment is not going to be nearly as useful as having something that like logs stuff to standard out as soon as it happens. There's just so much going on with this, like, that I think I'm going to want to be able to do a bunch of repeated runs of any experiment and then try to like correlate stuff to find kind of hidden state that I might be missing, because it sort of looks like right now there's some hidden state that causes this to either boot successfully or not boot successfully, and I just don't know what that is yet. Oh, there's a comment that somebody's sitting in the same chair as Tuco and theirs is also broken. Yeah, I've had this for a long time. I actually just recently got it back from a friend that I lent it to for a while. And it's been through a lot. I think I bought it in the 2008 kind of time frame. So I've had it a while, and me and another friend bought identical chairs at the same time, and the friend's chair, like, I remember repairing it multiple times because it's the mechanism that lets you either lean back or not lean back, like locks the angle, that just broke off, and I replaced it with something else. This one, I think the lean back mechanism still works, but it's mostly just torn up because Tuco has been clawing at it for a long time. Oh, that is an old pre-built Debian image, huh? 2013. Yeah, that link doesn't even go anywhere. Okay, whatever. I'm assuming one can just compile SIGROC on a Raspberry Pi fairly normally. Yeah, I mean, I think if I want to run this on the Raspberry Pi and actually have a recent version, I'm probably going to have to compile it. Gosh, anybody else remember libusb 0.1? Those were the bad old days. It's kind of cold outside, but I think Tuco likes the fresh air. GPIB. It would also be cool if this could stream data back from my oscilloscope, but I don't know if that's actually possible. Like, doing logic analyzer stuff on my oscope is great for like fast and triggered stuff. Like if I have a particular event that I'm trying to set up an experiment to look for, then that's just perfect. But if I want to just stream back bulk data and chew through it, then these little USB logic analyzers are kind of great for that, because I can send the data back and process it as it's being captured. I think I just need libsigrok decode, and sigrok CLI. I don't think I need that sigrok firmware package either. That is for a different logic analyzer than the one I've got. Yeah, that directory actually has firmware that I put there. That's the LA16FW. Okay. I sure love compiling on a Raspberry Pi. Yeah, I could try a different approach where I run Sigrok / PulseView on this same machine that you're seeing. I haven't done that so far because it's not straightforward to get the USB from the logic analyzer over to where that machine actually is. But I could do that. I might do that if this is too much of a pain. But so far it's actually been kind of nice to do stuff that depends on physical port access on a Raspberry Pi that I can just put wherever. Oh, lip tool. Get text. Setup tools. Sure do love build systems. Yeah, my condolences on the chair breakage. It was a promising chair, right? It's like comfortable and it was affordable, but there's some plastic parts where there really shouldn't have been. CIL. Yikes. I don't know what's going on with the glib 3 these days. I feel like I'll be doing alright if I never have to write glib code. What else did it want? Oh, is there a problem with diode.zone? Pull up some graphs over here. I should really just always have graphs. It is a little slow, huh? Oh. My monitoring for diode.zone's been kind of up and down today. Diode.zone is pretty low on memory right now. It's got 2 transcodes going that are both kind of taking up a lot of memory. The stream and 1 background transcode. Yeah, I need to restart a couple of like monitoring processes after this stream, but I don't see any immediate problems. But it'd be nice if I had more RAM for this VM. I'll have graphs for diode.zone hopefully in a minute if that comes back. I don't like not having graphs. Oh yeah, if there's still offices closing, that might be a pretty great way to get some good chairs. I haven't shopped for furniture in a while. Most of the chairs I've got are stuff that I've had for a long time. Yeah, why am I my graph's so flaky today? Oh yeah, PeerTube sure is fun, full of surprises. I really should have more memory for that machine. It's only got 4 gigs, and the physical machine is supposed to have 8 gigs, but I think there's some problem with the motherboard that's causing half of the memory not to show up. So it's just like standard hardware bullshit for me. Stuff only sort of kind of working. Okay, graphs are coming back. My monitoring on the public-facing server is maybe a little more delicate than it should be because it's a bit of a Rube Goldberg machine for security purposes. Like the monitoring machine, like the monitoring server is not directly accessible from the server that runs PeerTube. Yeah, this is I'm gonna keep an eye on this, but I think we're just low on RAM. Disks are doing fine. Knock on wood. End up using SSH on my phone way too much. Enable sale. I'd like to compile this SIGROC as an NFT and sell it. If Tuco's gonna settle down, we can get in a little closer. Oh, does it need oxygen? Interesting. I don't know if this is going to be for Python 2 or Python 3. Can I use pip to install this? Oops. IG object capitalized like that, sure. Good yawn. Tuco's content because he's in the softest available chair and there's a source of cold air in the room. I mean, if I'm going to use the SIGROC CLI, I don't think I actually need these, but it'd be nice to be able to go there. Oh, did I not? Did I just space out and not actually installed oxygen? Oh, let's get swig too. I don't know what version of swig it wants. Okay, do we just need some Python headers? I'm guessing it's just not picking the right Python version. Okay, now we're up to PyG object. Do I just have multiple versions of Python 3 maybe? Pretty sure we already did this though. Maybe not. Okay. Sure. Oh, I think I was like lamenting that I couldn't get the graphs on the computer that we're on right now, but I could always switch computers. Hopefully this won't glitch my recordings. Where'd you go? Whoa, loud boy. Hey. Oh. where do you want to be? Duke. To go. He is looking for stuff to get into. I've tried to cat-proof this place as best as possible, but he always makes me nervous when he's in one of those moods. Soft boy. Oh man, so many packages. It's always nice when someone like makes a list of all the packages you need for a particular build, because it seems like there's a decent amount of work involved in just like collecting that information. And of course that always depends on like the configuration you care about. So, you know, like in this case it's I want to use a USB logic analyzer, but anyone who wants to use like logic analyzers that require additional libraries would be out of luck in that case. It's nice to have at least like a starting point though. Tuco's giving me this look like he wants to jump up directly onto this touchscreen module. Oh, honey. Oh, don't go that way. Don't stand on the screen, honey. Honey. Tuco, that's not a good place to be. Tuco, no. Gosh, Tuco, don't do that. Okay. Let's close the door for a while. Tuco. Why does PyG-object need Cairo? That's such a weird dependency. 2 goes a handful sometimes. It's nice that at least, like in my previous setup, the like big open space that a lot of folks liked, it was nice in some ways, but one of the ways that it sucked is there was just no way to keep 2 out of anything. And at least here I can close the door. I'm gonna clean up that thing he knocked over while this is building. Big ol' spot of soldered dust where this fell. Still no PyG object. What's going on there? Oh, did I just not install PyG object? No, I used pip. Tuco always wants more attention right after he made a mess that I had to clean up. Such a cat. Oh, this is saying it requires Python 3.6. Maybe that's part of the problem. Man, you know, I feel like before I get super deep into any of this, I should check on how up to date this entire distro is. Like maybe I can just update my Raspbian. Raspbian stretch. What even is the current Raspbian? Maybe I should just completely rebuild this Raspberry Pi with more recent packages, because Python 3.5 is kind of old at this point, and then just like redo all these builds. I might just do that off stream so that I can shut this one down before it gets super late. I'm trying to focus on quantity more than length at this point for streams, so hopefully I can do this more sustainably if I don't try to drag each one out as long as possible. So, just looking at chat for a minute. Somebody's asking if I moved. Yes, I'm in a very different place than I was when I was streaming in, like, I don't know, 2018, 2019. I moved at the beginning of the pandemic, basically. I moved, like, right before COVID. Like, I was looking for a new place and moving and then starting to almost get settled in, and then COVID happened. And that's pretty much where I'm at. But yeah, I've been slowly trying to actually make this place nicer, and so this is kind of a nice little studio zone right now. Yeah, so I painted one of the walls green, set up this desky thing. Most of the equipment for this is actually in a rack elsewhere, so this can be pretty compact. There's just like a big old pipe full of cables, basically. And this is what I've been staring at. I've got a little monitor that I can look at through the ring light. And then a little electronics workspace over here. Yeah, I'm still basically just like barely at the point where this is kind of spacious and set up enough to use it. When I was streaming earlier this year and last year, this was kind of more partially set up, and especially like the streams I did in 2020 were kind of a mess because I was like streaming from the floor of this room and didn't have anything really set up especially well. Earlier this year I had some streams where I had like a zone set up kind of in like this corner where I was doing electronics, and then I had this editing desk kind of situation, but that was just too much like discontinuity in space. So here I've got the like kind of editing area over here and the So this kind of doubles as like video editing and doing computer-based streaming now. So I've got big screens over here I can use for my editing workstation. I've got like a little screen in the middle that I can watch while I'm on camera. And then I've got like these streaming utilities over there basically. So like this is the computer that's actually running the stream. And then I've got a little tablet that I can do chat from. And then a big microscope monitor that's just connected directly to the microscope so I can get low latency feedback from that. And then one of the more recent additions to this is this like tower of electrical instruments over here. And yeah, I painted the walls black so that the color spill from the green screen is not as bad as it otherwise would be. It's even got black ceiling under the ceiling fan so that when the ceiling fan is spinning it doesn't quite flicker as much. And these really long or really bright LED tubes, mostly there to light the green screen. Yeah, it's been nice. I mean, that's kind of why I've been trying to set this up better, is I want to get more like regular, kind of like everyday streaming going on and just have this set up so that I don't have to fuss with it too much. Right now, the most fuss really is probably just like setting everything up on all the different streaming services. And so I'd like to try to automate that again, but it's not too bad. Destruction's like Tuco's middle name, totally. Oh yeah, there's a comment about NixOS. I have not tried NixOS, and I really should. I know a bunch of people like it. Yeah, so the Raspberry Pi that we were just working on is right over here. So yeah, that's the voting machine motherboard we were just working on. Logic analyzer connected to the PC104 bus. And then that's a Raspberry Pi 3 running off of power over Ethernet. That's been just kind of my like electronics bench utility Raspberry Pi. So it's like a good machine to have a fairly modern distro on. So I should look around for what actually runs on Raspberry and see if there's something better than Raspbian even. Like, I'm sure there are some other distros that might be good for that, because I mostly want to use that for running things like SIGROC, where I'm like compiling stuff on the Raspberry Pi and using libUSB and GPIOs and stuff. The other option, if that's annoying, is that I could run it through this same demo machine that I was just like SSHing from. That machine is actually a VM on a Mac Mini, and so it's not the most powerful, but it gets the job done. Because it's a VM, I have to manually pass through any of the USB devices that I want to use. And so right now I've only got it set up to pass through the mouse and the keyboard. But I could try adding a pass-through rule for the logic analyzer, and we could try that out. But it wouldn't surprise me if we have bandwidth and reliability problems with that pretty much straight away. All the USB setup here is kind of weird. Like, I have 4 of these USB to RJ45 like USB over Cat6 adapters up here. Can't quite see them clearly at this angle, but it's that row of boxes that are right above that M audio thing. So there are 4 of those that give me 4 USB channels that are all separate from each other. but like I've got a bunch of stuff that has to go over that. One of those is dedicated for just sound. So I've got an audio interface that gets its own USB interface just for that. Then I have one each for 3 different computers that I use in this setup. But that means that everything that is going to a single computer, typically, unless it's the audio interface, has to share a USB controller with a bunch of other things. So if I was running the logic analyzer over that, then it would also be sharing with like the keyboard and mouse, which is not a big deal. But I guess I'd more worry about the like the VM situation, making it hard to sustain a transfer, because that's using like software USB emulation in QEMU. I'm using PCI pass-through for the graphics, but USB is not PCI pass-through because I need to share the USB controller with some stuff that's running on the host. But yeah, it's been nice to get this set up. I've got so I got OBS and voice meter doing the stream over there. The inputs are kind of all over the place. I've got a couple of USB inputs, a bunch of SDI inputs coming in through a Blackmagic DeckLink card. Basically the strategy is everything that I can get on the SDI card, I'll put on the SDI card. But then I've been using a separate HDMI to USB 3 grabber for like the computer screen. Mostly because the SDI setup doesn't work for 1080p at 60 frames. So if I was going to use the SDI setup for computer graphics, then I'd be stuck with 30 frames a second, or I'd be de-interlacing the computer, and both of those suck. I was doing that for a while, but this is a little nicer. Type 1 hypervisor. Those, you know, those terms are meaningless, right? I used to work at VMware, and I know, like, people used those, like, type 1 and type 2 and whatever. It's like, no, it's a hypervisor. Like, there aren't, like, rigid lines depending on, like, which part of the hypervisor you put where. Like, if you're running an entire OS, like to support the hypervisor, and you just like don't give people management of that OS, people think of that as like an appliance when really it's just an application running on an OS. And then even when it's an application running on an OS, like VMware Workstation or whatever, like those often from the kernel's point of view will actually try to like slide under the kernel and be talking to the hardware directly. So the layering on a real VM is never quite as clean as the marketing and the like the academic publications would lead you to think. But yeah, anyway, it's like QEMU running on Proxmox. So I've got the ability to do PCI pass-through. I just also wanted to share some of the devices. Anyway, I might put that on a more powerful machine at some point, but like a lot of my infrastructure here just runs on like junk computers pretty much, like stuff that is fairly old, and a lot of like secondhand like Dell machines and stuff from like offices that were getting rid of them and that kind of stuff. This machine that I do video editing on, which like I'm pointing to it as if it's over here, but it's in a rack with everything else. That's by far my fastest machine. It's got like, it's like a 10-core Intel, I don't even remember which generation it is, but it's something fairly recent with a lot of cores. Alright, well, I'm going to sign off. Like last time when I tried to end the stream, I ended up crashing OBS as I was signing off because I switched back to my like standby image, but I'm going to try that again, and hopefully I fixed the problem and it won't crash. If I even have keyboard focus, is that what I messed up? Okay. Yay, it didn't crash. Yeah, I think it was actually, I think I had the options set up such that it was trying to seek right away when it switched. Like it was set to keep the video file closed when it wasn't shown, but it was also not set to restart the video when it first shows up. So I think when OBS was trying to display it, it caused a massive seek that maybe wasn't indexed, or for some reason caused it to do a bunch of I/O. Anyway, it crashed last time and it didn't this time, so I'll consider that an improvement. Oh, that's interesting. There's a comment that Matt's trying to find his 4K 60 FPS camera with a real-time output. Yeah, so I have not tried doing anything with like 4K physical, like digital video. I've tried some like 4K streaming just from like the GPU, but yeah, I don't have any capture stuff that goes above 1080p 60, and it's probably more expensive than I'd want at the moment. I don't know what's out there for like real-time capture on a 4K 60 camera. You probably need a fairly expensive card. Anyway, I'll see you all later. Hopefully I'll be streaming again tomorrow, but I'm gonna try to not like pile up too much pressure, but also try to just like keep a regular schedule. So I'll see you soon, and keep petting Tuco until then. See you later.